Show that the line x minus y plus a times square root of 2 equals to 0 touches the circle x squared plus y squared equals to a squared. Also find the point of contact. Let's begin. So here we will start with the equation of the circle. We are being provided with the equation which is x squared plus y squared equals to a squared. Now clearly the equation is given in the standard form. So that means the center of the circle is going to be at the origin with the coordinates 0, 0 and the radius is going to be a unit. Now we need to show that we have the circle with center C at 0, 0. We need to show that we have a line whose equation is given to us. It's given that this line has the equation x minus y plus a times square root of 2 equals to 0. To show that this line is indeed touching the circle, what we'll do, we'll try to find out the distance of the perpendicular of point C and point A. Let's say the point of contact is point A. So we want to find out the perpendicular distance CA first. We'll be using a formula here. So here, let's suppose that we have a point with the coordinates x1, y1. And we have another line whose equation is given by ax plus by plus c equals to 0. If we drop a perpendicular from the point on the straight line, then this perpendicular distance will be given by the absolute value of ax1 plus by1 plus c whole divided by square root of a squared plus b squared. So we're going to use this formula to find out the perpendicular distance CA. So that means CA is going to be equals to the absolute value of, so we will take the coefficient of x, so that's 1 will get multiplied with the x coordinate of the center, that's 0. Then we take the coefficient of y, which is -1, and this will get multiplied with the y coordinate of the center, so that's 0 as well. And then we have the constant term, that's a times square root of 2. This will be divided by the square root of, we'll take coefficient of x, which is 1, square it, and then add it to coefficient of y, which is -1, and square that value as well. So let's further compute this value. So we have 1 times 0 and -1 times 0, they are both 0. So we have a multiplied to square root of 2 divided by square root of 1 squared plus -1 squared will be simply square root of 2, which means that the perpendicular distance comes out to be a. Now this is nothing but the radius of the circle. So we are getting the perpendicular distance CA exactly equals to the radius of the circle, which tells us that indeed the line is going to touch the circle. So we have proved the first part. Now our next goal will be to find the point of contact. So what we'll do, we'll assume that the point of contact has the coordinates. So let A has the coordinates x1 coordinate given by x1, y1. Now this particular point lies on both the circle as well as the straight line. So that means it must satisfy both the equation. So we'll start with the equation of the straight line. We will get x1 minus y1 plus a times square root of 2 equals to 0. All we have done is replace the value of x with x1 and y with y1. So if we isolate y1 from here, so y1 will become equals to x1 plus a times square root of 2. Now we can also use the equation of the circle, and we can say that the point A lies on the circle, so it has to satisfy the equation of the circle. So our circle is going to become x1 squared plus y1 squared equals to a squared. Now what we'll do, we'll replace the value of y1 with x1 plus a times square root of 2 whole squared. This will be equals to a squared. So we have x1 squared plus x1 squared plus 2 times x1 times a times square root of 2. Added to squaring a times square root of 2 gives us 2a squared. This will be equals to a squared. So x1 squared plus x1 squared, that becomes 2x1 squared plus 2 times square root of 2 times a multiplied to x added to a 2a squared minus a squared. So that becomes a squared. This will be equals to 0. Now we will try to find out the value of x1. We'll be using the standard formula, quadratic formula. So we have x1, this is x1. x1 will be equals to negative times the square root or the coefficient of x1. So that's 2 times square root of 2 times a plus or minus the square root of, now we will square the coefficient of x1. So 2 times square root of 2 squared, that becomes 8. And we have a as well. So squaring it becomes a squared minus, we have 4 times the coefficient of x1 squared, that's 8 times the constant term a squared, the whole divided by 2 times the coefficient of x1 squared, 2 multiplied to 2. So luckily the discriminant part goes away, so x1 will be simply equals to negative square root of 2 over 2 times a. So this is the value of x1. Now that we have the value of x1, we can find out y1 because we x1 plus a times square root of 2. We have x1 plus a times square root of 2. So let's replace the value of x1 with square root of 2 over 2 times a plus a times square root of 2. So this is going to give us, we have a common denominator of 2. We have negative square root of 2 times a plus 2 times a times square root of 2, which is going to give us a times square root of 2 over 2. So that's the value of y1. This can be also simplified as a over square root, negative a over square root of 2, and y will be a over square root of 2. So that means the coordinates of the point of contact a, that's going to be negative a over square root of 2, and the y coordinate will be positive a over square root of 2.